Welcome, everyone, to the Watering Hole podcast. I am so excited to have our guest today, Tyler LeBaron of the Molecular Hydrogen Institute. Everybody give him a warm welcome. This is a long overdue conversation, and I respect Tyler's work so much because we're all about empowering the people. So, Tyler, welcome.
Well, thank you. Thank you very much for having me and sharing some of this information and knowledge that we're going to drop.
Right. And it's so cool because I feel like your scientific lens and really giving that background. If you want to tell them a little bit about yourself, we can start with just who you are, maybe a quick bio.
Yeah, sure. Um, so I learned about all this area back in 2009, and we'll go through my story a little bit more. But that's when I was first starting my science studies at the university, which I then graduated in biochemistry. But I was always researching this stuff. I went to Nagoya University in Japan, researching on molecular hydrogen, and then later I did a master's degree in exercise and sports conditioning, also researching molecular hydrogen. And then I did a PhD, also researching molecular hydrogen, and that was in physiology. And since then, I've been very involved in the academic publications of scientific articles. My work have been published, I don't know, over 1,000 times so far by other scientific publications, other researchers out there. So I'm excited to share more of this. I also teach as an adjunct instructor chemistry and exercise physiology at the university here. So I'm just very passionate about the water, about molecular hydrogen. As you mentioned, I'm the executive director of Molecular Hydrogen Institute, which is a 501c3 tax exempt, science-based nonprofit. So we're not here to promote any product or anything like that. We're just want to share knowledge, our education, our research, and that's what we're all about. And so I'm happy to impart some of that.
I love that you said that. That was a big piece when we first talked was that you're not here to represent any product. And I feel like that actually keeps things non-biased and it keeps this conversation able to be spread with truth. And that's something that we both connected on is you're here to stand for the truth and so am I. And that really means a lot to me because we all know on our path there can be so many different opinions, and in my role I'm kind of the person that people come to like, Jilly, this person said this and that and the other, and I've done my best to do my research and my due diligence. And so I want to just take a moment and shout out my girl Jenny, who's in our community, and she connected us. And as soon as we connected, one thing that I really, really, really valued was that you were open to having these hard conversations about water, right?
Yeah.
And yeah,
Well, and a lot of it because I know that feeling. I know what it's like to really believe something, and then it seems like no one else believes you, and then maybe you are wrong, and then you're trying to follow the truth. That's what you really want, but the truth is you believe this is going to help somebody, but the other truth is it's diametrically opposed to what it appears the science says or something. And now we can reconcile a lot of that and explain some things. And I absolutely appreciate Jenny for contacting me, and because she came across things that she thought debunked the water basically, and she's like, well, basically I if this is where it's at, I need to investigate this more, right? And so she put forth the work and things, and she realized, okay, I learned a lot of things that maybe weren't necessarily true, but this opens up a whole new world of things that are true, and this is even more cool than I originally realized. I don't want to put words into her mouth, but
yeah.
again, it's just the fact that when you really care about something, then the more you should research it, because that's the benefit of science and learning how to research something, not confirmation bias. We're just going to look for things that support our perspective and reject everything that goes against what we're saying. We want to go a scientific approach, because when you do that, that allows us to get to the truth, and ultimately the truth is what will set us free.
Oh, yes, 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 yes. And your journey. So, for reasons we aren't going to say the name of certain water that we are going to be talking about, or the company to protect and stay in compliance with certain laws. There are no medical claims that are going to be said on this either. And we're really going to do this with compassion. And our intention is really to bring that truth and that peace, because there really is so much separation, especially in the water industry, and different water activists and different professionals all have different opinions. So we really want people to know that this is really going to be said with gentleness and perspective. So thank you so much for being open to this. I'm really excited to dive in.
No, absolutely. I love this stuff. And this is what allows science to advance. And I think that as we go through, what we'll try to do is we'll try to differentiate between what are known facts, right, that we can agree upon, like what is 1 + 1? That's 2, right? If somebody said that's 15 or something, then we can't really have a conversation. So there are known facts. Then there are things that we don't know, right? And that forms the basis of opinions and informed opinions and so on. So we'll try to separate things out a little bit, and sometimes things can be confusing, and we want to say, oh, we can't believe that. And it's not so much that it's not true, it's because we don't fully understand it all the way. And so I'm just saying, be patient as we walk through things, because sometimes it's because we don't fully understand something. All of us are actually logical. I know typically we say that people are illogical, we're all emotional based, which is true. It is true. We do base our decisions off of emotions, but then we substantiate it and justify it logically. However, there is still part of us that are logical, and if something doesn't make sense logically, then we're not going to believe it. It's very difficult to believe something that just defies every part of like what I'm about. That doesn't make any sense. And so we can walk through things over and over again, make it slow, go slow, and then it'll click, and then you'll be like, wow, okay, that makes sense. I get it now. And that'll empower you to have that foundation. So we go principle upon principle, and if you start right, you can end right. But if you start wrong, yeah, you're going to be really confused real quick.
Yeah, and I do want to say for my community and those who know me that Tyler's journey in the water, navigating his own water path. Maybe you can tell him a little bit about where you started. Again, not saying any company's name or any type of water, but your journey, and I just laugh at your experience when you were in college too. I think that's a really big piece.
Sure, yeah, I'll share that. I'm sure that everyone will enjoy that too. So, well, I was first exposed to this concept of electrolyzed reduced water back in 2009. And at first, it kind of made sense to me because I learned that our blood pH is alkaline, and so we kind of want to have an alkaline pH. And of course, if your blood gets acidic, like if you have like diabetes or some other conditions or whatever, well, that's really bad, and it could be harmful for you. And so it kind of made sense. Maybe there's something there. Anyway, I went ahead and I bought a machine at the time, and was, hey, if this works, like even a fraction of what the claims were, then hey, this could be really good for me. But at heart, I was always a scientist. Like I always really want to understand, like, how is this working, right? How is it making it alkaline in the first place? Like, what is this negative ORP people are talking about? Like the charges and like all these things. And I got a few books. I got a lot of marketing stuff. I was looking at all the websites, scouring everything online, and of course, I was talking to all the I guess just other people in the business, right? And asking them questions, and other, I guess doctors that were in the business as well. And, I quickly found that everybody contradicted everybody else. And like, I was just so confused. Like, what is the truth here? Like, what is the basics? And so when I got back to the university, I was like, well, there's got to be some foundational truths that are categorically true, that are verifiable, like 1 + 1 is 2, the example I gave earlier. So I went to the university and I asked some of the chemistry and physiology or biology professors about the water and some of the claims that I had heard, and see if I can make sense of the alkaline pH and the negative ORP, and just some of the claims that I heard. Well, as I began telling them about this, you can imagine their response, right? Like, what did you say? But that doesn't make sense. You can't drink alkaline water and then change your blood pH. Or what do you mean about this claim and an alkaline water and curing cancer or something, or oxygen, or all of these things. Like, what do you mean by the ORP? And I was like, oh man, like, okay, clearly they know what they're talking about. I could sense it, not just like an arrogant level of confidence, but I could see there's a real substance here. And they were actually, polite, even though I didn't feel like it, because they actually would walk me through. Like they showed me some things like in a textbook and some equations and things, like showing me like this is why this doesn't make sense. And I'm like, oh man, this is challenging. But deep inside, this was my truth, right? I felt there was something to this. And I was like, and I told them, I was like, I just feel like there's really something here. And as powerful as I thought that was, scientifically, they were like, yeah, but you don't really know that until you do a study, until you really determine for yourself, right?
Your
So I'm
study,
like,
I would love to do my own study too. Oh,
we'll have to talk about that because there are some things that we can do to, anyway, that's another quick thing. So, but that's exactly what I did though. I was taking a psychology class and I learned about all the methods of how to like do double blind, placebo controlled, randomized crossover studies, just different things so you can ensure that your study is controlled. And I applied the same methodology, and I got a group of people, and I established a baseline of what I called individual lactate threshold running. Put them on the treadmill. Got a baseline, like I said, how far they could go. Then I gave, they randomized them in a crossover way. So half of them received the placebo water, other ones received the other electrolyte reduced water. And then they did the same thing, a week later, and then they switched waters after a washout period, and then did the same thing, and then did it again and measured, how long they went for time to exhaustion, and then went to the math tutoring lab, and so we could upload the results in the SPSS, statistical software, and do statistical analysis of this. And we found that statistically there was a small difference, but it appeared to be meaningful that those drinking the water could exercise a little bit longer. And I was like, okay, so I wrote all this up, and there was an undergraduate senior research conference, and I'm like, well, I'll just present there. So I presented at this conference, and I'm by myself, like by my poster, and everyone's asking like, so what department are you with? Who is your mentor? And I'm like, I didn't even understand this. I was like, I don't. What do you mean? Like, I'm just presenting the research that I did as a freshman, right? And then they were also judging the posters, and the same professors I had talked to before were actually the professors who were judging the posters. And they came to me and they looked at my poster and what I did, and they're like, "Wow, you did it. You
wow.
you did the study." And I was like, "Yeah." And so they're just looking through my methods, everything, like, "Wow, that checks out. That checks out. Yeah, you did a good job." They were intrigued by this because like it totally defies logic. But again, science, real science, does not pathologically reject things just because it doesn't comport to what they believe, right? A real scientist is like, hey, let's look at the data. If the data is there, then we need to accept it. The data was there, and so they said, okay, would you write this up and let me look at this report some more, right? And so I did. And so in my write-up, I was just reading all of these papers and everything, but I started coming across hydrogen gas because when you do electrolysis of water, and this is something everybody really needs to understand, the definition of electrolysis is what? Electrolysis, by definition, is the decomposition of water into hydrogen gas and oxygen gas. It's very simple. That's the definition. And that's what this process is doing when you make electrolyzed reduced water. You're making hydrogen gas. So I included a few references to hydrogen gas in my report, and I gave it to the professors. And then I come in, and so one of the professors emailed me biochemistry, and he's like, hey, let's talk about this. And it comes in, and he hands me this report that was published in 2007 in Nature Medicine, which is one of the most prestigious academic journals out there, okay? And this article shows that hydrogen gas can act as a selective therapeutic antioxidant because it can selectively get rid of the bad free radicals and leave the beneficial ones alone. That might be confusing for some, but it turns out there are good and bad free radicals.
That's super important. Yeah, because most
very
people,
important.
all the free radicals are bad. There's a balance. Yeah.
Exactly. And hydrogen is unique. We're kind of digressing, but just to put that point there, hydrogen is unique because unlike other antioxidants, it can discriminate between the good and the bad. Okay. We'll talk about more about why that is. Well, we'll kind of say that for later. It's such a small molecule, like it doesn't have a brain to fit inside of okay, that's going to, but okay, going back to the story, he printed this out, handed it to me, and he said, you know, Tyler, I think there's something here.
Wow.
Now, when he said that, I like felt like this energy or this something like just tell me this is what I need to do.
Mm,
So that's what I decided. I'm going to study hydrogen gas. I'm going to understand this and I'm going to do all the research. And so I still was looking at all the stuff I could about the water, like all the other claims, just researching everything. Like I heard stuff about like, oh, it has a reduced surface tension. It has a different, boiling point and freezing point. It has like all these other properties. It has like microclustering aspects. It has changes in nuclear magnetic resonance imaging, the resonance spectroscopy. Well, I was in the chemistry department, so all through my years, like I did a lot of organic chemistry, and so I actually took the water and we put it into the proton NMR, so we could look at studies. So I investigated all of these things. In the physics lab, we had a dynamometer, and I went and I tested the surface tensions of the water and got like very analytical reports so I could see if there are any differences, investigating everything one at a time, and at the same time looking at all the literature to see what has been published. We always joke in the science circles that an hour in the library saves a year in the lab. So
wow. And this is important because a big piece I feel like was you're being innovative, and there wasn't as much about this water and the hydrogen back then. So
right.
you're like kind of spearheading this, being able to do that and have the resources to do that. And you were young, right? How old were you?
Yeah, so I guess at the time I was, 22 years old or so.
Wow.
So yeah, and I was super, geeking out. And I was always in the lab. I was always in the lab. I was always talking to professors, always getting their support. And they were so good to me. They were very supportive because I mean, I understand now because as an instructor at the university myself, anytime I have students who want to do research, I want to bend over backwards to help them because it is amazing when you have somebody who really just wants to get things done. And so I was just really blessed that from the physics and the chemistry and the biology departments, they're like, oh yeah, let's do this. Here are the keys to the laboratory. I had two keys at one point to different departments of laboratories, so I could just go in and try doing some research. It was a really cool experience. But all of this, I started converging more and more on the importance of two things: the negative ORP and molecular hydrogen. Okay. I found in my personal research that as long as you control for pH and ions and a bunch of other things, as long as all those were controlled for, there was no change in, say, the surface tension or the NMR, the resonance structure, which people had incorrectly attributed to changes in the structures of the water. We could control for that, and lots of other papers have since been published, also showing that that's not necessarily an indicator of a water structure, but other things that we can go into. So, but what we did find, number one, is that I knew that the ORP was something amazing. There's something special about that voltage potential. I didn't quite understand it, and I could tell from the scientific literature that hydrogen gas is crucial, is essential to the therapeutic benefits because of many studies at the time. Well, at the time there were only like 50 or so studies compared to over 2,000 publications today, right?
Wow.
So a pretty massive difference. I'm happy to say I've contributed to around 50 publications myself just on molecular hydrogen now. So it's kind of interesting. When I started, there's like as many as I have actually contributed to the scientific literature.
Wow.
Um, okay, so I wanted to investigate this, right? So the first one was the ORP. I need to understand that one. And it's so interesting how fascinated I was with this versus how simple it actually is. Well, I say simple now because I spent so long, but it's actually all has to do with hydrogen gas. That's where it comes from. So maybe we can spend just a little bit of time talking about the ORP just so we can understand like what this magical thing is. Because what I remember when I was learning about this all this in the first time, people were talking about negative ORP in terms of like, voltage potential, like with your cells, they have a voltage potential, and like maybe you have like charges on ions, or the water itself has a voltage potential, or has electrons in there and it's negative. Like there's so many things about it. But what I did, and this is actually a part of a research project I did in analytical and quantitative chemical analysis, analytical chemistry. In fact, this is my book right here for this class. You can see
Mhm.
quantitative chemical analysis, and this was the book that we used, and they have a whole bunch of information about ORP. And I was like, okay, so the information is here. I need to understand this. And so I was going to figure out what it is about this water and what is the connection with everything. And
Mhm.
so I did a whole project where I took different concentrations of hydrogen gas and dissolved it into the water and then measured the ORP at differences in pH. And I found that the ORP would change as a function of two things. One, the hydrogen gas, and two, the pH. But primarily the pH. And this is all based upon what's known as the Nernst equation. Okay, now we don't need to get into that now, but I will say that it's interesting just how neat everything circles back around. It turns out that the ORP has, so as we know, it goes like, from negative 1,000 to positive 1,000, or of course it goes further, right? But what is the 0 point, right? What does that even mean? So if it's 0 millivolts, what does that actually mean? Because it's just a reference point. Just like we reference how warm or cold it is outside, right? We would say that water is freezes at 32 degrees Fahrenheit, right? Or in Celsius is zero. That 0 degrees Celsius is that reference point, right?
You're
100 degrees.
saying you wanted to know how it was being measured, not just
Yeah,
the measurement, but how it was being measured.
exactly. Yeah. How it was being measured. What does the scale actually mean, right? And then what is responsible for that measurement? What is the chemistry behind that measurement? What is actually telling us? How do we know if it's meaningful or not, right? And so first up, you have to understand what the millivolt, what the scale actually means. And that's what I was bringing about, like with the temperature scale. It's just a reference point, right? We arbitrarily assigned when water freezes at 0 degrees Celsius. That's all that it means. And then if we're above, if we're 10 degrees, 20 degrees Celsius or whatever, like, room temperature, or 37 degrees is our body temperature, degrees Celsius. Okay. And then of course you can be negative. We know if it's the negative degrees Celsius, it's pretty cold outside, right?
Right, right.
So ORP is the same thing. So what is that 0 point? This, you're gonna get a kick out of this. The 0 point is this: if you took water and you dissolved hydrogen gas into the water at 100% solubility, right? 100% hydrogen gas, and you measured the ORP,
Uh-huh.
we're gonna call that number 0. And
Mm.
that is called the standard hydrogen electrode, or She electrode. It's
Yes.
the She standard hydrogen electrode.
Yeah.
Yeah, no, it everything goes back to hydrogen. And
Yeah.
so when you if you as you measure if you take the pH and you put it to 7, for example, and then you measure the ORP, if the pH is 7, then you're going to have an ORP about negative 420 millivolts. If the
Mm.
pH is 10, then the ORP will be around negative 700, negative 800 millivolts or so, right? Anyway, this was just starting to answer a lot of the questions I had about the relationship between the ORP, H2, and the pH, and it really combated a lot of the crazy misunderstandings that I had that I couldn't understand about the ORP being a part of like an actual like voltage or some electron thing, or like, but now I understand it is not independent, but it is part of the presence of hydrogen gas.
So, one of the questions that I have is you mentioned when we talked about the hydrogen tablets and the temporary measurement of ORP in the tablets versus the hydrogen that is produced through electrolysis. So what is that difference? Because I've heard multiple people talk about, oh, well, ours is sustainable, add this to, whatever. How is that difference? How does that
Yeah.
play out?
Yeah, excellent question. So let me explain a couple of things that will answer that. If we understand that ORP is simply a function of the presence of hydrogen gas and the pH. The higher the pH, the more negative the ORP. The lower the pH, the less negative it is. And you only have to have a very, very small amount of hydrogen gas in order to get a negative ORP. All
Right.
right. So now when it comes to say the tablets, well, the tablets typically add organic acids in it so the reaction happens fast. And so it produces all this hydrogen gas, which you can see the hydrogen gas being produced, or you can light it on fire too, right? You can see this happening. But because the pH is acidic, if you measured the ORP, you're going to have only a negative like 300 millivolts.
Mm.
But if you took the tablets after it dissolved or whatever, and you added something to make the pH go high, like ammonia or Drano or lye, or even the strong alkaline ionized water or something, the ORP would be negative 800 millivolts,
Right.
or
This
more.
and this is why it's whenever I'm doing my water test, I can test, I won't say any companies, but like regular alkaline water from the store that says it's 9.5, but the ORP is not negative.
Right, exactly. Because there's no hydrogen gas. But if you added just a small amount of hydrogen gas,
Hmm.
it could be negative. And in fact, we can anyone can do this demonstration. This is a very fun chemistry demonstration. Maybe one time we can do this live or something.
Yeah.
But you can take water that has hydrogen gas in it, dissolved hydrogen, and then take something and then measure the ORP and then add a little bit of vinegar to it and watch what happens to the ORP. The
Right.
ORP will go from like negative 800 millivolts to negative 300 millivolts,
Hmm.
just like that. Okay. But by adding just a couple of drops of vinegar, you did not change the true hydrogen gas concentration.
Right.
It's
And this
still
is
the
what they're
same.
claiming with these artificial alkaline. It's not true alkalinity,
Yeah,
right?
well, it's I understand what you're saying, but that's the problem with terms and definitions because alkalinity is different than alkaline, and none of this is the same as ORP or hydrogen gas.
Wow.
So
Yeah.
so that
Huh?
yeah, so in order to and that's I think is why a lot of the confusion is out there and people like are debating with each other. They might even be saying the same thing, but they're talking past it because they're not defining what they mean by the terms, right? And as the saying goes, those who control the definition of the terms wins the argument.
Wow. Because I've had clients that have been drinking our water and then go buy the alkaline water from the store and they're not getting the same effects at
They
all, but it
don't.
literally says it on the label.
Right. And
And
this is actually there's actually two critical points that people must know. And
mhm.
number one, you cannot get the benefits of fresh alkaline ionized water by just drinking high pH alkaline water because there's no hydrogen gas in it, right? If
Yes.
if it,
Okay.
if it doesn't have a negative ORP, there's no hydrogen gas in it. Now that's an easy one. Most people already know that. In fact, most people know that if you have alkaline ionized water that's been sitting in the fridge for a while or under the sink or whatever it is, or in the bottle for a long time, that the ORP goes away
Mhm.
and there's no therapeutic benefits. And
Mhm.
this is actually the coolest thing. Now that we can measure the concentration of hydrogen,
Yeah.
we can actually understand why it is that so many people have realized that, hey, the fresher you drink the water, the
Yes.
better.
And this is so funny because I've seen others market this as it never goes away. And ours last for, however many days. And I'll tell my clients it's like getting a juice. Go to
Right.
the juice bar, get a green juice, whatever it is. You're gonna want to drink that right away because
100%.
eat it days later or drink it days later, right? It's the same concept.
Exactly. Well, and now we can even make another analogy because we know we're talking about the hydrogen gas. If
Mhm.
we're going to drink a carbonated beverage, like say carbonated water, because we're not going to drink carbonated soda, God forbid. Um, so let's say we're drinking carbonated water, though. How long can you leave that open before it goes flat and it doesn't taste carbonated anymore?
Oh.
Right? Well, hydrogen gas has a half-life even shorter than that. So if
Mhm.
you can't leave your carbonated water sitting in the fridge for days on end, much less can you do that with water that contains hydrogen gas. Now, remember, when it comes to that ORP, you only need a very small amount of hydrogen gas to get a negative ORP.
Mhm.
So this is why the ORP, listen, this is why the ORP is actually a very problematic tool because you
Right.
cannot compare the therapeutic properties from one machine or one water to another. Because you can easily have one water that has very high levels of hydrogen gas, and the ORP is say negative 400 or negative 500 millivolts because the pH is close to neutral or slightly alkaline. And then you can have another water that has an ORP of negative 800 millivolts, but the H2 concentration is only like 0.1 milligram per liter or even less, below the therapeutic level. And yet it has a net ORP of negative 800 millivolts. And so there are machines out there that I know of that I have personally tested, and you can measure the ORP and it gives a negative 700 millivolts, but you never can get a detectable level of hydrogen gas in it because it's so low. And that answers the question of why is it that some machines seem to produce a therapeutic benefit and others don't. Yet they both have a high pH, a negative ORP because of the hydrogen gas concentration.
And this is really important because there are the claims around I've heard people say, oh, the ORP is it's wrong. Yet you're saying it's not necessarily wrong, it's just not the most accurate way to measure the hydrogen in the water.
Right. It's often misused. Exactly.
Right.
Yeah, I mean, there are inaccurate claims about the ORP. Like if people are going to say that the ORP means it has like free electrons and is providing voltage to the body or something, that's not true. The ORP is a distinct property of dissolved hydrogen gas in the water, according to the Nernst equation. Going back to the standard hydrogen electrode, like this is literally high school chemistry that we learn about. That's very well understood. It just can be very confusing when we're applying it to what we're talking about.
Yeah.
So there are misunderstandings about the ORP, but it's so important that people know that you cannot use the ORP to therefore say, oh, this water is good and this water is bad. So I have talked about one problem with the ORP, which is just what I said, that just because it has a high negative ORP in this water doesn't necessarily mean it's going to be therapeutic, because you have to know what the concentration of hydrogen gas is. And that's why some machines are therapeutic and other ones are not, despite them both having a similar negative ORP.
Right. Okay. Tell me the second thing, and then I have a question.
Okay. The second one is also about your current machines. Because there are people, and you probably have actually experienced this or heard about this. Somebody's drinking their water from their machine. It still gets a high pH and negative ORP, and yet they're just like, I just don't feel the benefits anymore. And then their friend buys a machine. They try their water, and they're like, that machine's working better. Or they upgrade to a new machine, and they're like, no, this machine works better. Or they deep clean their machine, and they're like, oh my gosh, this works so much better now. Like, I don't know what it is. Even though the pH and the ORP measurements were all the same. Why is that? Because when the calcium deposits onto the electrodes, it prevents the hydrogen gas from dissolving into the water. And that's why over time, you can still get that same negative ORP, but you don't have as much hydrogen gas dissolved in the water. But having a new machine or cleaning your machine as recommended by the company, that's going to help ensure that you are getting the dissolved hydrogen gas in there. So again, that helps us understand why it is that some people have had this experience where they drink the water and like, I'm not feeling the benefits anymore. And all of a sudden they do a deep clean or they drink someone else's machine. Like, your machine's more effective than mine. It's not. You just need to clean your machine.
And this is important in buying used machines on these third-party sites. You never know what you're going to get, because the way that people maintain their machines is very important. We're really big on that. And so I have a question.
I have one more thing to say about the ORP.
Go ahead.
This is actually really scary. And this is really important because the ORP has been misused so much that there have been companies who have developed products that can make an alkaline pH with a stable negative ORP, like a company called Real Water. Look them up, Real Water. And what happened? What happened was, you can make a negative ORP not just with hydrogen gas, but you can add other chemicals there. You can add toxic ingredients, toxic chemicals that can give you a negative ORP. And this company did that. And it resulted in serious harm, including a death. and they have been sued for millions of dollars. You guys, you can Google them and look them up, but they had a negative ORP. And
Mm,
so again, you just have to be careful when you see a negative ORP water. You don't know what is causing the negative ORP.
mm,
Hopefully it's hydrogen gas. When it comes to alkaline ionized water, we know it's hydrogen gas. Okay, that's good. But you have to determine and you have to ensure that you know what's creating the negative ORP. And then second, you don't know what the concentration of that molecule is making the negative ORP. So you have to determine what that concentration is in order for you to really make a comparison. So
wow.
that's also important to put out there.
Very important. Thank you for saying that. And so as somebody who's walking my water path, and I love our water systems. They've changed my life so much. I've always been curious about the earth and how, so I went on these like water pilgrimages, and I would go to these springs that were so far away from society, and I would test the water with my ORP meter and my pH drops. And I'm curious, does the earth make, because I've tested it and it's come out to a negative charge and a high pH. And what I've been noticing is that people like don't believe that water should have a negative charge, or sometimes I test a spring that a lot of people go to fill up and it's not a negative charge, and it's like, does the earth naturally create hydrogen water?
Yeah, that's a good question. So there's a lot actually to unpack with that. So again, when we talk about negative charge, I'm assuming you mean, yeah, the negative ORP, right?
Yes, negative RP with the hydrogen gas in it.
So that's actually sometimes is true, may or may not be, because as I just said, there are a lot of ingredients or chemicals that can make a negative ORP. Some of them are
Right,
good for you, some of them are toxic for you.
right.
So you can measure springs, and it may be beneficial and it has a positive RP. For example, if it just has a rich levels of silica and manganese and magnesium and things, this is very well known to have therapeutic benefits, but it will have a positive ORP. But you can measure a negative ORP because it has maybe hydrogen gas in there, and we
Mhm.
know that has therapeutic effects, or maybe even has a little bit of hydrogen sulfide in it or
Mhm.
other sulfur compounds, which also can have very important therapeutic effects, and it'll also give a negative ORP. Okay, so we have several types of chemistry that's going on, and that's one of the problems with an ORP meter is you don't specifically know what chemical species is really contributing to that negative ORP. But to answer your question, can there be hydrogen gas in some of these waters? Yes, absolutely, because it's a natural process. It's very natural because you have for example, you can have reactions from basalt catalyzed reactions. So like rocks and minerals deep down in the earth that are still in its zero valent state, they can then react with water, like iron, for example, to produce hydrogen gas. That's a very natural process. Bacteria can also be metabolized in foods, and they'll take hydrogen ions and they'll add electrons to it, just like an electrolysis, exact same process. That's the definition of electrolysis, is adding electrons to hydrogen ions, they make hydrogen gas. Bacteria can do the same thing. And when it does that, it produces hydrogen gas or maybe some hydrogen sulfide, for example. You also have lightning is another example. Of course, if lightning strikes the water, then that's going to decompose the water to hydrogen gas and oxygen gas.
Yeah, and that's the nature piece of this and just honoring the earth. I went to a cave in Nordenau, Germany, and the science on the posters where they get the water from like way back in the cave, and people will sit in the cave and they basically say that the hydrogen in the cave is actually what's healing. And that's what I find this connection with the earth with hydrogen is, it's like, okay, yes, we have our water systems, and I'm excited to talk about it because people will say, oh, your machine electrocutes the water. And when we talked, and they'll make the claims, and we'll get to that in a minute, the structured water conversation. But I was like, well, wait a minute. Lightning does electrocute the water, and
Yeah.
earth, that and I asked you, and you were like, it's the same chemistry happening. So could
Yeah.
you, yeah.
Yeah, and it's kind of it's unfortunate how words themselves can be used. I mean, the term electrocutes just has this kind of this negative connotation, right? I mean, you could say it energizes the water. I mean, we could do this all day. That's why it's important to go down to what exactly is happening. So let's forget about the words we're using. What exactly is happening when lightning strikes the water?
Mm,
Okay, well, electricity, electrons. Okay, that's what makes up a lightning, right? It's electrons going towards positive charges, right? These electrons then get into the water. The electrons are not stable in water. They electrons have a very high voltage potential. They are unstable. You cannot have free electrons in the water. They're going to react with something very quickly.
mm,
Electrons are negatively charged, so they want to react with something that are positively charged. In water, you always have things, water itself always produces positively charged ions. These are called hydrogen ions. And
mm,
this is why water, it's called the self-ionization or autoprotolysis of water, where water is always creating H plus ions and OH minus ions. And I think we did that chemistry a while ago, showing that beautiful relationship and equilibrium between H plus and OH minus. And it's just combining and forming water and then separating to form H plus and OH minus all the time, right?
yeah.
That's the ionic product of water. Now, those H pluses are there, and you have electrons there from the lightning. Now these electrons are going to attach to the hydrogen ions and form hydrogen gas. Okay, that's the chemistry. Electrons into the water, they combine with hydrogen ions, and then hydrogen gas is produced. Okay,
Mm,
now let's think about what is the chemistry with electrolysis with machines. Okay, you
mm.
plug your cord into the wall, electrons come through the wall. This is actually not true, but for the sake of this statement, then the electrons eventually are going to be at the electrodes. And where are those electrodes going to? Where are the electrons in the electrodes? Right, the metals. Where is that going to go? They're going to go into the water, and then
Mm-hmm.
they're going to combine with what? With hydrogen ions to
Mm.
produce hydrogen gas. The chemistry is exactly the same.
Wow. And so why do you say that the electrons are like you mentioned when you plug it in, you're like, oh, this is not true, but for the sake, what do you mean by that?
Oh, well, just because we want to say that when you plug it in, the electrons are going to come from the outlet and travel through the cord really fast. But actually, you have the copper ions have these d orbitals in the molecular structure. And so the electrons, they just kind of push this electron over here and it pushes this electron over here. So the electron over here is not really the one that's going to actually go into the water. It's actually the electrons that are already at the vicinity of the electrode, and there's these, and then they're always switching places, and there's quantum hopping that's going around. So
Oh
it's
my
kind
gosh,
of
I've been
a
talking about this so much, quantum leaping. I've actually been saying this a lot. And so you're saying it's not like one electron over here plugged into the wall is going through the cord into the water. You're saying it's like a chain?
yeah. It's gonna interact with this next electron, and that one's gonna go and so on until you get to the electrons that are already at the electrode interface. Um,
Wow. And yeah, and there's differences within the quality of water systems as well. And I've dove into the switch mode, the off and on as the electrical current goes through it, like turns off and on. And the difference between a medical grade and the Japanese Ministry of Health and Welfare is that it's a transformer and that holds the electricity to a certain there's a reason why it's actually certified as a medical device in the Japanese Ministry of Health and Welfare because it's able to sustain that. And that piece for me was like, wait a minute. So what you're saying is when there's these claims about the water electrocuting or the machines electrocuting the water, what you're saying is that water does that,
yeah,
right? It's the same
nature.
chemistry as nature. Yeah. And I've heard it being said, oh, it rips the water molecules apart, it rips the structure apart. And I'm like, but water does that like on its own, right?
Well, it goes into the water separates as acid base chemistry, forming H plus and OH minus ions.
Mm-hmm.
That happens all the time on its own, and that's what pH is. but water itself doesn't just spontaneously create hydrogen gas or oxygen gas. You have to add electrons there. But those electrons happen all the time from nature, such as the minerals in the ground that we talked about that are still in its non-ionic zero valence state, or from lightning, for example, from bacteria. So water is doing this all the time. In fact, one of the most natural things in life and one of the best things for us is plants. Well, water participates in this redox reaction as well, because why plants, what do, right? They consume CO2, right, to make the plant structure, and they produce oxygen for us. Where do they get the oxygen from? Where do plants where do plants, how are they making the oxygen, right? Where are they getting that from? And that is the number one signature of life is oxygen, because without life you cannot have oxygen. Oxygen is not stable, because it's a diradical. So where is the oxygen coming from? How is it being made? It's being made from plants using the water, because it'll take the sunlight, and then the photons will excite the electrons, and there's a specific process in the electron transport chain of exciting the electrons using the photon energy to excite the electrons, and then eventually that can break the water molecule apart, and then you get the hydrogen ions, which are used for energy, and then the oxygen is then combined together with another oxygen molecule, oxygen atom, to form an oxygen molecule, and now you have O2 gas. So, but like if we're looking at it that way, like that's exactly what nature is doing, in the sense of allowing us to get oxygen. So I guess there's that angle too, if we want to talk about water.
Right. And it's splitting. I've heard it being called splitting, right? The water splitting, or when it splits, it's creating the OH negative and the H plus. It's like that process is a chemical process that happens in nature. And it's funny you bring up plants, because I like to joke that humans go through photosynthesis as well. And right. And that photosynthesis has a lot to do with the water in the plants. And water gets overlooked a lot in that process. But I'm glad you brought that up, because, okay, I want to just preface this with, I have so much respect for Masaru Emoto's work on the water molecule structure and how the emotions affect it, even though a lot of people debunk it and say it's pseudoscience. I have so much respect for people who share about water structure. As me, myself, has actually gone to a school in Tokyo and have seen the water molecule structure on a microscope. Yet, there's this piece that the claim that our systems destructure the water through electrocuting it. So can we talk about water structure with so much love and compassion? Because I want to share this lens, because obviously I'm a huge advocate for that information, yet I had to really sit with myself on well, hold on a minute. Let's look at the science and hear from a different lens. And you really help to make sense of it from what we have proven. Yeah.
Right. Well, and I appreciate you starting out with just your respect for people who want to bring shine light to something as miraculous and marvelous as water in general. And I think so too. I've actually been there in Japan, and I've been to the lab, and it has two different freezers, and so it is kind of a fascinating thing. And so I agree, but. And then you're right. It has been debunked with high level scrutiny, and then we can say it is pseudoscience, but that's not necessarily a pejorative. It's a descriptive adjective. Pseudoscience just means that it's not scientific. It doesn't mean that it's not meaningful or that it's not important, right? I mean, if you have a partner and you love them and you're trying to say this, that's also pseudoscience, in the sense that it can't be scientifically objectively shown, right? But that doesn't mean it's not meaningful or significant, and or that it's real. It just falls outside of the realm of science, and that's one of the weaknesses of science, is that we can't test things that aren't scientific, right? But it is the best tool that we have to maintain objectivity and rationalization and understanding, so that when we get these confusing questions, we can put the correct lens in, so we can differentiate between what's potentially a scam and could be hurtful to us, and what could potentially just be beneficial for us, and what is maybe just harmless, and we can interpret it how we want, right? And
Right.
that's kind of where things are at with the water structure claims in general. There are the fact is there's been a lot of research that has been done on water structure and in general, but the only definitive evidence that there is of changing water structures to any meaningful degree is what is already very well known and very well accepted, which is the structure of the water inside of our cells, inside of our body as it is.
Yes.
Okay. And so like for example, if you take a paper towel and you soak up all the water, you can then take that paper towel and you can just squeeze it and wring it out, and all the water comes out because the water's not structured. But you can't take your steak and then just squeeze the steak out or something and wring it out, even though it's 90% water. You
Mm,
can't just do that. And that's because the water is structured, literally, bound into the microtubules and into the protein constituents and the conformations of all the cellular structures and everything. And that's so this is the structured water. And we know with disease and conditions and aging, and there's a lot of these structures start to change because our proteins are breaking down, because we don't have the right ions and solutes and electrolytes and all these things that are going on. And if you don't have those, you can't maintain the right structure of the water. And
mm.
so if we see where there's destructuring of the water in a cell, we know there's a problem with that. So it's one of the hallmark signatures of there being a problem, right?
Okay.
Now, what
Inside the body.
yes, inside the body, inside the actual cell, right? This is structured water at the interfaces. Now, that's materially different than the bulk liquid water that you drink, right? That is in your glass. And if you were to somehow structure this water in any meaningful way, well, then it would be like, a crystal, and that's how you make a crystal, right? You freeze it, and now the water is structured, and now it's a solid,
Hmm.
right?
Yeah.
That's so water is beautiful because it can be liquid and it can change all these ways. I mean, just to just to think about this too. This would be cool, and it will kind of dovetails into this. But think about how light the water molecule is versus, say, oxygen or nitrogen gas. So oxygen, if we look at the periodic table of elements, oxygen atom weighs about 16 grams per mole, and the oxygen molecule, there's two oxygens, so 16 plus 16 is 32. So that means that oxygen weighs 32 grams. Okay, 32 grams is how much oxygen weighs. What about water? Well, what makes up water? You have one oxygen, which is 16, and then you have the two hydrogens, and each hydrogen is 1 and 1. So 16, 17, 18. Water only weighs 18 grams. Oxygen weighs 32 grams. Yet oxygen is a gas and water is a liquid, right?
Mm,
So why is water not just floating away just and being a gas just like oxygen is?
yeah.
Right? And that is because of the hydrogen bonds that occur in the water. The water molecule makes these hydrogen bonds, and this is what makes its structure that's always changing at a femto timescale. And so if you could somehow change the water structure in some way, you it could actually be problematic for our bodies. For all the claims you can say it's going to be good for you, you can use the same rationale to say why it's going to be bad for you, because the water molecules themselves are absorbed into the body, into the cells through the aquaporins, and the aquaporins are a protein channel, as we know, that they accept one water molecule at a time in a linear fashion, not as a cluster. I mean, a microcluster itself is already larger than a lot of the cells are. So, I mean,
Mm,
a water molecule, we're talking about something that's like, a nanometer long. Itself, the full diameter of the water molecule is already very, very small. And so it's going to be able to go through that aquaporin, and it actually changes orientation as it goes through, so that
mm.
it can have a complete separation and an excellent filtration to get that pure water molecule into the cell. And so that's very important. So if you were to somehow alter those dynamics, then it could be potentially harmful for you, because now you actually can't absorb that. Like you can't absorb an ice into like an icicle into your cell or something, because it's not
Right.
it's not a liquid water, right? So what we're trying to just point out here then is there is a lot of really powerful and amazing and meaningful things about when we talk about water structure in general. There is a scientific aspect, which we know, which is the water inside of our body, inside of our cells. And then there are other areas that are still being, researched and investigated, such as the changing somehow the energetic states of the water molecules in the liquid water that you're drinking.
Mm-hmm.
And right now, there's no strong evidence or objective clear evidence that this water is structured and this water is not structured. And therefore, it becomes problematic because now anybody can just get the water out of their garage or out of the sewer or whatever it is and say, oh, look, my water is more structured than yours. And your water is not structured, and it becomes this fight and everything. When water should be what bringing us together, it should. But
That
just
is
as the oldest tales known to man is the wars have always been fought over water, and before it's about like your actual life, and now we're fighting wars about the structure of water or something when it's a non-issue. We can all and we should all be able to enjoy the water for what it is.
which almost debunks, because I know that when you go to these schools or wherever you get the picture of the water on a microscope, you have to get it registered. And the point is that you're taking a picture of the water, and the way I did it, in the freezer outside of your body,
Yeah.
and then taking a picture of that and saying, this is right, like structured water, better for the inside of your body. So you're basically saying that it's a claim,
Right.
and that yes, it was a beautiful experience for me, because I was like, wow, I could see the structure changing. I loved seeing it. But there's so much of like, oh, well, I'm going to send the picture of my water in, or I'm going to get my water sent in and see and take a picture of it to see if it's structured. And you're saying that is not a valid way to prove that that is beneficial for your body, or even that it's going to be structured in your body, right?
Yeah, because the structure in the water is going to dictate on the ions and the solutes that are in the water itself. Because it's just like when you take water and you put it into like Bruce Lee said, you put water into a cup, it becomes the cup. You put water into a container, it becomes the container, right? And so in the same way, when you put ions like calcium, magnesium, chloride, fluoride, whatever it is, then the water molecules surround that. And in fact, there's an ion. As you know, an ion is simply an atom or a molecule that has a charge to it. An electrolyte is when that ion is dissolved in water, and water molecules surround that. That's the definition of an electrolyte. So water molecules are going to do that. And depending on the concentration of the electrolytes, the charge of the electrolytes, and the identity of the electrolytes, that's going to dictate how when the water molecules freeze and those hydrogen bonds form their associations, that's going to dictate what the structure looks like. Okay. And so it's all going to be dictated upon the solutes that are in the water. And so like so when they freeze the water, for example, the idea is to enhance the majestic feeling of everything that water brings to us. So you want to get a good crystal. So when he was asked about how does he get these samples, right? Well, he goes and he freezes a whole bunch of samples, and he's going to find the samples that look the very best, because that's what you're after. But that's also what we know is confirmation bias, right? Where you're cherry picking the data, looking for the very best one and throwing out all the ones that don't look very good. Right. So that's not really a scientific way, but it doesn't mean it's not meaningful. Just like you had a meaningful experience while you were there and gave you a love and passion for water in general. That's the experience and the spirituality that we can extract from that. But that doesn't mean we can then correlate or take that to then say that this water is therefore going to be good for your cells or something, because we need a different type of evidence. We need what we call scientific evidence to make those types of objective claims, especially when we talk about somebody's livelihood.
Right. And so the claims about our systems, our water systems through electrolysis, electrocuting the water and destructuring the water, is basically a claim that you can't prove.
Yeah, you can make the exact same claim. You can say the opposite, right? You have just as much evidence and substantiation and logic to say that you are going to, instead of electrocute, you're going to energize the water. And instead of destructuring, you're going to structure the water. Instead of making the water bad for you, you're going to now make the water good for you. Like, you have just as much logic and rationale to say that on both sides, because it's not a scientific point, right? And that's why when people want to talk about the benefits of the water, we want to go to the objectivity. What makes this water good for you? If it is just it's because it's energized, then your other people are going to say, oh, so you electrocuted. Well, now you're just fighting, right? But if we say this water has hydrogen gas in it, well, what are they going to say? Because we have hundreds of publications showing the benefits of hydrogen gas.
Mm-hmm. Mm-hmm. And that's very interesting to me because I really do sit with all of the drops that I've gotten about how we speak to our bodies and how we crystallize the waters in our bodies. And I feel that within my body. And then I really had to sit with, okay, yet I have to be very careful with the way that I share this as scientific fact when it really isn't. And having, and who knows, in the future, that those studies, I don't even know how we would actually prove that. Yet I do feel that throwing around these claims can actually be dangerous, because there is a piece that I want to go into where part of the logic around the electrocuting the water and destructuring the water is that our systems are leaking metals into the body. Now, I'm not going to say any names. I'm going to keep the private. Yet I had a client who went and got a blood test. And the person who they got a blood test for is obviously not a doctor or a scientist. They were certified in that. And they send in the blood test, it comes back, and they do a report. And in this report, this person does not support our water systems. They are getting their information from others who have said that the water electrocutes through the electrolysis process, and then therefore says that the amount of metals in your blood are from this water system, which was a big red flag to me. And I already knew to ask you, because I'm like, what is scientific fact? What is the medical? And what is just straight up opinion? And I sent you the information and I asked, and what you said back to me was really illuminating, because I have also had these like blood tests done at like trade shows, where they prick your finger, and they had told me certain things, and then they sold me certain supplements. And so I really feel like bringing this to the forefront again, to have this conversation and open up this conversation, because my client came back and said, oh my gosh, there's all these metals in my body. And I told her, we got to get second and third and fourth opinions on this. She went and got her own opinions from other water analysis. And this person told her that the amount of metals are like 0.00000. Like, this is nothing to be worried about, and actually said the same thing that you told me about, like, we are constantly exposed. So if you could give perspective so that people know their discernment, because I think, once we think, oh, it's a blood test and I prick my finger and it must be right, they must be, it's almost like kind of you're expecting a medical person to tell you, but yet it's not.
Right.
So
Yeah,
yeah.
it's very unfortunate, and I'm not really familiar with the specific type of blood test that was done. We'd have to do some more investigation. So just talking generally about this, we do have to be careful about different blood tests and things that are out there, because sometimes like there are some tests you don't even do a blood test. They just kind of put some crystals up to your forehead and then tell you have heavy metals, or they tell you to buy your supplements or something.
Right.
Where do you draw the line? Right. And I think a lot of us want to just say, well, I wouldn't fall for that. But yet, if that were so true, then why do you have hundreds, thousands, tens of thousands of people that do fall for it every single day? And then when it happens to us, well, we want to be, we're so adamant, like, no, but I know that this is because I had this mold toxicity and then I did this. And we have all these ways to rationalize how it is. And it could be something totally different. And that's why it's important to just learn how to understand what the scientific facts are and use scientific principles, so that we can discern between what is accurate, what is not accurate. And some of these blood tests, they'll do like these live blood analyses, for example, And that there could be some merit to some of the things, but sometimes you get people saying, look at all this mercury in here, and look at all these parasites, and look at all this. I mean, if that were true, you would not only be in the hospital, you'd be in the mortuary. I mean, you'd be in the funeral home, right? You would be dead, because it's completely impossible, some of the claims that people say. But yet, when you see this on the microscope, it's just like, oh my goodness, like I've got to do something about this. And so it can be very motivating, and it's a kind of this fear-based tactic that unfortunately people use to maybe sell supplements or to sell their machine or to and it's not always done nefariously, because sometimes people really believe what they're saying because they've also been taught that same way. So that we have to have a lot of, I guess, patience and understanding where people are coming from, but we all want to arm ourselves with having that protection of critical thinking and scientific facts, or else we could be we could be harmed by some of these things, right? And have this anxiety that's really just unwarranted. You know, some of the things you were saying, like they have all these metals and platinum and this and that in their blood, and well, how would they ever know that it's from drinking the water? There could be so many things. I mean, if you just live outside with all the pollutants and the very small micron particles that come from the people's exhaust, that can get into our lungs very easily and get into the bloodstream, that has a much higher probability of causing, metals in the blood than ingesting something, because our body is actually pretty good when it comes to ingesting things, to not allow absorption of a lot of things that would otherwise be bad for us. So we just have to be really careful about that. But we also don't want to just say, well, because it's approved by the Japanese, therefore it can't be bad for you or something either, because that also takes away the objectivity. The reason why, the whole reason why the Japanese had to have the medical approval is because they want to make sure it's safe, because there are potential issues that can occur if they don't follow regulations. Like you talked about, like the different, like power current and things, like they have the ISO certifications and things. That's to ensure certain operational aspects of the machines. And so they need to have these types of approvals in order to even be sold in Japan. So pretty much all the water ionizers in Japan have to receive this approval. And you can look it up. It's the Japanese Ionized Water Association. It lists like 17 something companies, and they all have to have the same nuts and bolts and basics, following these schematics outlined by the government, so that it doesn't cause some serious problems. And then even with that, there are some caveats which we have published about. We looked at the research, and there it is possible that in certain cases, if you're drinking super high pH water or whatever, that there could be problematic things with that. But we shouldn't get our all this anxiety or whatever because some doctor or whatever claims to look at your blood and say, oh, you're killing yourself with all these toxic metals or something. We need to learn how to objectively evaluate, well, what exactly is that test, and how are they making their conclusions?
Right. And that's what I feel was so empowering about the situation, because I truly feel that people are doing it from their hearts, and they're doing it because they think that it's helping. Yet they're going back to that measurement. It's like, what exactly is being measured here? And if somebody says, oh, that's a harmful level, and then you go to another water specialist and they're like, but this is 0.00000,
Yeah,
whatever.
exactly.
It's
Yeah.
like, wait a minute, that measurement, where did you learn to say that measurement meant this? And now you have to do this whole heavy metal detox. I mean, there's so much misinformation, and empowering people to, I mean, it's even with going to the doctor. I just tell people, like, make sure you're getting more opinions, because you can't even take
Right.
all of that power, right? Yeah.
Well, I completely agree. That's why getting people's perspectives and talking about things, because you can't be an expert in everything, right? But that's why getting people's opinions, but also knowing your sources, where you're getting things from, because there are established facts out there. There are things that we know, like we know the blood pH should be slightly alkaline. So if somebody's saying you should be slightly acidic, well, that's this doctor has this opinion and this doctor has their opinion.
Yeah.
It's not like, well, we don't really know if the blood pH is alkaline or acidic because two doctors disagree with each other. No, that's
Oh,
not true. We actually do know. And
yeah.
and
Yeah.
that frustrates me so much because I get people who will say things like that I am wrong about something because another doctor makes another claim, and I'm like, where's your data? Where is your data at?
Yeah.
And the ironic thing sometimes, because we've done a lot of research showing that hydrogen gas is the exclusive therapeutic property in the water to make it therapeutic. And people might message me, is like, you're completely wrong because look at all this data, or this doctor says this. So I ask for the data. They'll send me a bunch of data and on scientific articles. All of them that they sent me support my position and refute their position, including, ironically, the articles that they sent me that I am a co-author of. And I'm
Oh,
like, did you even look at the
oh
articles you're sending? Because I am clearly the co-author of that article.
Oh my gosh. And yes, learning how to read these articles, that was big for me when I first started researching electrolyzed reduced water. And like even that there is this claim that electrolyzed reduced water mutates the DNA. And there's this study, and I have a friend who reads medical articles. She was like, this study actually like is promoting our water, not the opposite. To be able to differentiate those two.
Yeah. Yeah, 100%. It can be confusing. It absolutely can be. But I
Yeah.
think a lot of people, if you just read the title, you might get an idea of what the article is actually saying. It's just funny because sometimes people will do this article dump and like, this proves it all. And yet the articles, if you just look at the title, they actually show the exact opposite of what they're saying. And
Right.
so
So
we
what is your take on that? What is your take on that of ERW and the DNA? Have you seen those claims about how ERW will negatively affect the DNA?
I'd have to look and see what they're specifically saying. You're saying it was a study that has that? Because the only thing I can think of, if it's an actual study, is that there are some studies in vitro where ERW with supplemented platinum nanoparticles can disrupt the DNA of the cells and kill them. Now, here's the kicker: the study is on cancer cells. It
Mhm.
killed the cancer cells and did not affect the normal cells.
Oh,
So you
I've
have to
read
know.
this study. I've read this study. Wow.
So you have to look at the cell line and understand if it's a cancer cell line or not. Because we
Okay.
often will do studies and we can see that we can cause DNA mutations with this therapeutic product on cancer cells, but it does not happen in normal healthy cells.
Wow, wow, wow. And this is okay. I love that we're flowing into this already, where what advice could you give people on how to distinguish and discern and right? Like I really
Yeah.
appreciate how you're empowering people to do it themselves, to be able to translate this information themselves.
Yeah, well, number one, you should, like you actually started out, your objective should be the truth, and you shouldn't get your feelings hurt because maybe something your cherished belief, right, is not what it actually is. Because as you learn what the truth really is,
Mhm.
you'll be entered into a whole other world, a whole other universe that will really benefit your health and everything about you a lot more. So I just want to say first, I appreciate your effort, and going back to Jenny, that she had that foresight and desire to really delve into that. So that's the first thing. Don't be worried if you read something that makes you feel uncomfortable and makes you feel like, no, that can't be true. That is called cognitive dissonance, and that's a normal psychological feeling when what we're learning contradicts what we feel and believe, and we just have to research it more, and then it'll make sense of one way or the other, right? So that's number one. And of course, I'm always big on getting to the objective data, to that, what are those scientific facts, and if we can base and understand those things, then we can go a lot further. And it turns out you don't have to become a PhD or a super scientist in every area in order to evaluate claims, right? If you just know simple things like hydrogen ions are positively charged and hydrogen gas is a neutral molecule, then when somebody says something to you like, well, hydrogen is a negative free radical or something, then you're just like, wait a second, I thought that hydrogen gas was neutral and hydrogen ions are positively charged. Then like all of a sudden that logic doesn't make sense, right? So there are certain aspects that if you just know some simple elementary level chemistry, that
Mhm.
you'll be able to um, evaluate and debunk things all by yourself without having to go to some outside source. And that's ultimately the goal. So I know you and I talked about like the educational courses, and maybe we can kind of dovetail into that a little bit.
Yeah,
Um,
yeah, because I think just to say this, for those of you who have been following my journey with water, I originally wanted to be hydrogen priestess. Like when I like back in 2017, because I was like, it's the hydrogen. There's so like we're not giving the hydrogen credit. That was my angle back then. And then,
yeah.
I was like, water, because water priestess, more people will get it. And it's so funny how over time it's come back to that and over again. So for me, when I heard about your hydrogen courses back then, I think it was 2019, I think. When you first came out with those ones, those early ones, I was excited. And that's actually how I learned all the benefits, which we haven't even gotten to talk about the benefits yet. But why don't you go into the course first and then we'll close it with the benefits? Yeah.
Sure. Yeah. So the courses, if you go to our website, molecularhydrogeninstitute.org, okay, again, we're a science-based nonprofit, tax exempt, and we are focused on the research, the education, and the awareness of hydrogen. And these courses I put together it's taken me over 10 years to put them together. And right now, level one is available, which is 6 different courses. And anyway, just to talk about them just briefly,
Mhm.
you're going to learn the basics of what is science in the first place because there's a lot of misinformation about science, including, unfortunately, from so-called scientists, people that have done science, but they like have forgot what the basics of science, like what it really is. And so we talk about science. We talk about the importance of, scientific studies. Like, what does that mean? Why are they important? Why do we do them? We really go through things really basically. We talk about then going through some basic water chemistry just in general so we can get terms and definitions that we don't like these debates we're talking about, right? We're not going to get very far if you think electrons are positive and I think they're negative, or the other way around, right?
Mhm.
But if we both have a base understanding of what we're talking about, we can really start to understand. So we literally start with things like that. This is an atom. This is a molecule. Electrons are negative. Protons are positive, right? This is what an atom is. When they combine with something else that makes a molecule.
Mhm.
And then there's quizzes to make sure you're grasping these concepts. And then we go through the different species of hydrogen. That right there is like a number one question, is like, because all these types of hydrogen, like, doesn't water already have hydrogen in it, or how is this different than hydrogen peroxide? And we go
Yes,
through
I've gotten
all
that.
of these aspects so people can learn, because there are literally an infinite number of questions that can be answered by one simple truth. When you know the chemistry behind water's H2O and hydrogen gas is H2 gas, then you can know, yeah, that's not hydrogen peroxide.
Yeah.
So therefore,
Yeah.
no,
Yeah.
the answer is no, right? So
Yeah.
but it allows you to do this and to picture things like that. And
Yeah.
again, this is written at an elementary school education level. So you don't have to have like this high school background or even if you forgot things. It's written at that level. And then we go through like hydrogen water, like, well, how long does hydrogen gas last in the water? Well, how do you even measure it? And then finally, what are the benefits? And then how do you talk about it? Because like when you're talking about the benefits of molecular hydrogen, like there's even like elevator pitches in there. There's like this little the bullet points people can like talk about and memorize so they can make sure that what they're saying is correct. It gives you just some pointers as you're talking about this to not like shoot yourself in the foot and then like you get all like tongue twisted and you don't know what to say anymore. So that's all in the courses, and it'll take between an hour to 2 hours per course. So the
Mhm.
entire thing will take anywhere between 6 to 10 hours to take. There is a final comprehensive exam,
Mhm.
this is not something where you can just passively watch some videos and then call it good and make a checkbox. You are going back to school. Your brain will be challenged a little bit because there'll be quiz questions, there'll be exams. You'll go through this, but you will feel so accomplished as once you go through these, and you will know that this is the science
Mhm.
concrete foundational information. In fact, to really illustrate and emphasize this point, because there are so many courses and water courses even that are out there that like it's just people's opinions and like, well, I kind of think this and I think that or whatever.
Mhm.
We have worked diligently to ensure that everything is mainstream basic science that everyone will agree with. Okay.
Mhm.
In fact, these courses are in the process of being offered through the university where I teach at, as well as through the technical college as well. So that as
Wow.
people learn these basic principles of hydrogen and the benefits and the chemistry, you're going to be validated and learn more and that way the more you learn from other chemistry textbooks, if you talk to another biologist or doctor, you're going to feel more comfortable and more confident in what you've been taught, as opposed to if you learn if you I mean you
Yeah.
can imagine if you learn the benefits of alkaline ionized water and everything you've learned is like is not true, like it's because the water's been energized and it's the alkaline pH and it's the structuring and it's the free electrons in the water, and then you take just a basic chemistry course,
Yeah.
you're going to finish that chemistry course thinking you've been duped and scammed, and
Yeah.
every doctor is going to tell you you've been lied to and you've lost a lot of money and you're ridiculous, and you probably have leprosy and all your family's going to run away from you because you're just trying to tell them this pseudoscientific hogwash snake oil, right? And now
Exactly.
that's
Yeah.
diametrically opposed, of course, if you learn that the benefits of the water is simply you purify your water, you add hydrogen gas. This is the process of electrolysis, that how it happens. The
Mhm.
hydrogen gas has these benefits. And then you take a basic chemistry course and you're learning about water chemistry and acids and bases and electrolysis. It's like, yes, 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 I know that. I know that. Exactly. That's right. And you feel more comfortable. And all of a sudden it confirms your desire and your mission and your passion and everything.
And it's really allowed me to, I think that's why I was so keen to giving hydrogen credit back then, was that it makes my job easier because I know that a lot of people are receiving what other people think. And even the conversation about we didn't know this back when you started. And so, of course, there's other hypotheses on
Yeah.
why this water is doing what it's doing. And to be able to say, okay, you know what? This is what we know.
Yeah.
So if we share what we know, it actually makes our job easier because then it doesn't get twisted into all these other things,
Yeah.
which it feels like even just the energy of this podcast, it's like we're just cleaning it up. And sometimes it's hard because we're like me in the structured water picture, like I've been so, I don't want to say attached, more so.
But influenced and moved, and it's been a
Yes,
personal journey. Yeah,
yes,
it's understandable.
yes. And it doesn't say that you're wrong. It's just that there is innovative evidence that we've learned over time since I started this 10 years
Yeah,
ago that actually proves it helps you
yeah,
actually have these higher level conversations with people around chemistry, and you'll be able to learn the things to be able to stand in it, which is why I felt we had to ease into this. We really had to ease into this because little by little, I feel like as we've done our webinars, you've done calls for my team, little by little, we're finding the truth. And the truth, you can't say the past was wrong when we
right.
didn't know the truth yet.
We actually never fully talked about that, how important that is, Jilly, because these water ions, let's remember, in 1931 they started using this stuff. In 1960s they were approved by the Japanese ministry, right? In 1990s research started going on and they were showing these benefits. When was hydrogen gas really shown to be therapeutic? In 2007. One of the largest companies in what the water ionizer industry did not come to America until around 2005, a couple of years before this 2007 Nature Medicine publication had come out. Right? That's just one publication. How how do you think that you can take one publication and all of a sudden everyone in the world knows about it? Right? That's going to take years of education, people like you, right, educating people and finally getting that word out, right? So it took like another 10 plus years before people started gravitating towards, oh, it is the hydrogen. There's hydrogen, something about the hydrogen here. And so That's that's why if you look at those early studies in the 1990s, they tell you right there, we don't really know exactly the mechanism. Here is our conjecture. Here's our hypotheses, and they hypotheses and made a number of hypotheses about the benefits, about what it could be. And it wasn't until post 2007 that many articles went through and they found that when you removed the hydrogen gas from the water, the benefits were eliminated. And the only exception to that is when there were an additional platinum nanoparticles in the water, which alone could also have therapeutic effects in vitro. We don't know if that's clinically relevant or even maybe harmful. More research needs to be done on that. But for those interested, we published an article called Electrolyzed Reduced Water, Review Number 1. Molecular hydrogen is the exclusive agent responsible for the benefits of ERW. And this is not just a study. This is a comprehensive review of all the studies that are out there that have been done. And these other scientists have demonstrated this. In fact, the largest ionizer company in Japan, Nihon Shrimp, well, we just mentioned a company, but they're the ones who initiated all of this, right? And they're doing lots of studies. They have so many articles where they are saying, and we have found that the exclusive agent in the water is hydrogen gas, right? So it's finally, to your point, we didn't know this back then. So we should not fault neither ourselves nor certain companies nor our leaders for telling us that this water works and we think it's because of the alkaline pH or the ORP or because of the charge or because of this, because of that. Well, they're just, we're trying to do our best here, right? So now we know it's because of the molecular hydrogen, and we can have objective evidence. To your point, we can look at the scientific studies, and now I think a lot of people, if we tell them the benefits, the suggested benefits of molecular hydrogen, they look at the studies, they can make their own decision about whether or not they want to include that in their lifestyle. Right? There's hundreds of studies for them to look at, and they can decide, is this enough evidence? Because for some people, like the FDA, for example, there is not enough scientific evidence to say that hydrogen gas or hydrogen water is going to have meaningful clinical therapeutic effects. It's not there yet. And scientifically, I will say the same thing. We don't know, because we don't have a 10,000 study population looking at one specific disease, all these specific markers, like all these specific, that's what is required to really have that definitive proof. We don't have that. We have instead a whole bunch of independent studies from researchers all around the world showing a lot of really powerful, favorable evidence, right? And for some people, for maybe a lot of people, perhaps the majority of people, that is enough to weigh the pros and cons and say, pretty high safety profile, looks pretty good, I'm going to take the risk and do it, right? But people can do their own calculus, and they can make their own decision. And this is going to make it so much easier when we look at the objectivities, because going back to like the structured water and other like charge claims and other things, just consider the hypothetical, very sad example. Let's just assume that there's an individual with a disease that hydrogen water could totally cure. Let's just say hypothetically, right? We're not making disease, this is the hypothetical thing. And hydrogen water could really benefit this person. They're just the right person, just the right condition where hydrogen water could really help. And the person selling them is selling them hydrogen water, except they are not talking about hydrogen. They're only talking about the structured water, maybe a little bit of hydrogen as well, right? Another company who has no hydrogen whatsoever is selling them structured water, and maybe the machine costs less, maybe it costs more, but they have a really good sales pitch and they have a lot of really fancy and scientific sounding stuff or whatever, and they're making these bold claims about their benefits of their structured water, the same claims you're trying to make, and they end up going for the other company that does not have the hydrogen, and then this individual dies because they didn't realize the hydrogen. Now, right, just look at the other way around. You show them the evidence on hydrogen. This is what we're about. We don't have any evidence on the structured water. Ask them, where's the evidence? The burden of proof is on the individual or the company making the claim, not on us to refute it, right? So we ask where is their evidence at? Where is their scientific papers that shows and supports their claims? They don't have that. Here's my evidence. Here are all these publications. You make your decision. They look at it. I think I'm going to go with hydrogen water. I talked to my medical doctor, my medical doctor says, maybe it'll help me. I'm going to try it, right? The medical doctor's not going to say that about, your a super magnetic vortex structured water or something, right? So,
I mean, it depends. It depends on who
well,
you.
it depends on where,
Yeah,
yeah, but on average, right?
yeah,
Um, anyway, that's
yeah.
again why it's so good to be on this objective level of,
Right. Right. And I feel this conversation is going to spark a lot of, right, well, this evidence and that evidence. And this is what I love that your course teaches is how to sift your way through that. And I do feel that our partnership and why we set this up and educating on hydrogen really equips me with the knowledge to be able to stand on that truth. And if there isn't physical evidence that is provable through science, then how are we supposed to stand on these claims?
right.
And that's when the claims get thrown around. And for me, it was like, yes, I had to sit with the uncomfortableness of the structured water conversation. And I had to really ask myself, well, Jilly, you're here to stand in truth. So can you just put that ego aside and just look at this objectively? And it's really taught me, and I feel like this is one of the lessons that water has just really taught me is how to remove my identity out of it
Yeah.
and really look at what's in front of us. And I feel that as this movement grows, more people are going to see the magic of hydrogen. So
Yeah.
let's go into the benefits. Just give us a few things. Some people listening to this are going to be like, okay, you guys just went so deep into hydrogen water. What do you even do?
Absolutely. Yeah. Let's talk about some of those benefits. First, I just want to, again, my appreciation to you and your willingness to, I guess, put the ego aside or put things aside and look objectively at the science. And I want to point out that you did it correctly because you did not dismiss the meaningful experiences that you had, right? That love and that passion and that excitement and the respect and everything, you can maintain all of that and that energy that propels you forward. You can maintain that and not, throw the baby out with the bathwater. But
Mm,
and, and
yes.
I just hope that everyone else, as they learn that we can focus on the hydrogen and this verifiable evidence.
Mhm.
If you've had wonderful experiences or this idea of structuring the water or whatever, then hold on to that. Let that be of comfort or something to you. But just know that there's more to the story and that hydrogen can really provide you with that additional evidence. In fact, with the structure story, there's research now indicating that hydrogen gas itself, when it dissolves into the cells, it also influences the structure of the water. Because again, it is a solute, and so that can influence the structure of the water, and that could be part of the mechanisms of how hydrogen gas works. And so there's a lot that's going on to that, but again, it kind of goes back to the structure, or the structure goes back to the hydrogen itself as well. And so again, I think that's very humble and wise of you to have done that because I unfortunately there are people who learn the truth, so to speak, and then they just kind of feel depressed and they throw the baby out with the bathwater, and there's no reason
Yeah.
to do that.
Or they like bash or they say that we were wrong. These things are wrong. And I see it with other things too. You find out some diet is better and it's like, this was wrong. No, that is what you knew at the time.
Right.
And there was new information that was presented to you. And for us to innovate and grow as people, we got to be able to say, it's like you're loving who you were as you're
Mhm.
embracing this new version of yourself, right? It's the same thing with this science. And what are the benefits of hydrogen water?
Yeah, exactly. Okay, so we talk about these in our course, but I'm briefly going to just touch on a couple of aspects, right? Um, First, we talked about the antioxidant property, and I'm just going to mainly emphasize on this because why is it better or different or superior compared to other antioxidants? Because there's lots of antioxidants out there. Well, it turns out that as we mentioned, that there are good free radicals and there are bad free radicals. Now, these good free radicals, that's actually what's essential for our bodies to communicate with the cells. That's like our immune system. It makes free radicals, and those free radicals can then kill the pathogens. When we exercise, we produce a lot of free radicals. Those free radicals then activate signaling pathways to increase the amount of mitochondria. That's the energy or the powerhouse of the cell, basically. It does a whole bunch of things to make us, better and faster and stronger. That's the signaling that these free radicals are doing. And we have shown in especially in animal studies that taking high levels of exogenous or supplemental antioxidants can actually negate the benefits of exercise training. So you can imagine, yeah,
Oh,
think about this. You can imagine training. You're like, I'm going to be healthy, set a New Year resolution, and you start your 8 week or whatever month, program, and you're like, well, antioxidants are good for you, so I'm going to pop those every day too. And
yeah.
at the end of your your training session, you don't have any of the benefits. You're not faster. You're not stronger. You have blunted, mitochondrial biogenesis. You don't have the improved insulin sensitivity. All these benefits are negated or mitigated because you're taking these antioxidants. And again, because these free radicals are critical signaling molecules that modulate and mediate the benefits of exercise training. And it goes even further. Back in the day, they found these observations where people who smoked, which we know cause a lot of free radical damage, right? It's really bad for you. Smoking, the leading cause of death, right? Largely attributed to an excessive amount of oxidative stress. But they found that smokers who ate more carrots and had more beta carotene, they tended to thrive or live longer, not thrive, but they lived longer, they did better, they fared better than people who smoked that did not get as much beta carotene. It makes pretty good sense, right? Because beta carotene is an antioxidant, vitamin A, and they're getting a lot of free radicals. So therefore, it was proposed, it was concluded, it was suggested, hey, if you smoke, make sure you're taking, beta carotene. Make sure you take vitamin A because you've got to quench those free radicals. And so that was the recommendation because it made sense. I mean, that how else? What else would you conclude?
Right.
And then they're like, we should probably study this just to kind of really see just how good of a benefit it really is, right? Because we know it helps, but like by what extent? As
Right.
they did the study, they didn't finish the study. Any idea why? They did not finish the study because those taking the vitamin A, the beta carotene, antioxidants were dying and getting lung cancer faster than the people on placebo.
Mm.
Yeah.
So what does that mean to the hydrogen being the antioxidant?
So I'm gonna talk about that, why it's unique. So first off, in this study, of course, they used higher doses. You could say it's synthetic. You could make all these things. Yeah, all those arguments can be valid. Some not so much, but point is they were still these antioxidants, and it did not work the way they were saying, because the fact is we still need to have a certain amount of free radicals. Now,
Mhm.
hydrogen gas is unique because it is a selective antioxidant. Like I said, it only goes after the bad free radicals, and it does not
Okay, I see what
neutralize the
you're
good ones.
saying. You're making a point of the difference of antioxidants. So when somebody's marketing like, oh, over here is antioxidants, it can actually mitigate what you're saying. Whereas hydrogen as an antioxidant literally selects,
Yes.
like it's selective. And you
Right.
said the word earlier, you're like, it discerns. I'm like,
Yeah.
how? Have we
Yeah,
figured that out
it discriminates between the two.
yet? Yes.
That's why it's so important. So you have good free radicals like a superoxide radical or nitric oxide, which is responsible for vasodilation. These are good free radicals or reactive oxygen species. And then you have bad ones like the hydroxyl radical or peroxynitrite, another potent oxidant, which is just really, really pernicious. It's terrible, cause lots of damage. Yet hydrogen gas, if you put hydrogen gas in in the same vicinity as, say, hydrogen peroxide, which has beneficial effects at the right concentration at the right location, which is all regulated by the body because the body's pretty smart. It can do this. Okay. If you put hydrogen gas next to those, there's no reaction. But yet, if you put it next to the hydroxyl radical or perhaps even peroxynitrite, then you could get a neutralization reaction. And
Hmm.
so, to your question, is how is that possible? Well, it is because hydrogen is such a rather a stable molecule. That covalent bond between the hydrogen molecule is pretty strong, so it can't easily break. And that makes it very selective because it turns out that the worse a free radical is for you, the stronger its oxidative power, the stronger the stronger its oxidizing effect. So the hydroxyl radical is very damaging because it will react with anything, including your DNA or the nucleotides or whatever. It's just so strong, it will rip anything apart, including molecular hydrogen. And when it reacts with hydrogen gas, it forms water, H2O, because it's just OH radicals and the hydrogen gas, okay? But yet, another radical like nitric oxide, which is not near as potent of a radical, and it has a very critical biological functions. It binds to CGMP, and we don't need to get into that, but it has some very important aspects. Nitric oxide cannot react with hydrogen gas. And that's what makes hydrogen gas unique and selective, because it can discriminate between the good and the bad.
Wow. Wow. And that piece of it, that difference, I feel like this is, have you, this might be a little bit out there of a question, but like, have you studied how the DNA is held together by the hydrogen bonds?
Absolutely, yeah. That's a core part.
And have you studied how the hydrogen gas affects those bonds, those hydrogen bonds in the expression of DNA in the mitochondria?
Okay, so this one is a little bit complicated because they're related but independent of each other. Hydrogen gas, like I said, has that strong covalent bond, and so hydrogen gas itself does not play any part with the hydrogens that are holding the DNA together. Those are just simply hydrogen bonds, that like the hydrogen bonding in water molecules, or the hydrogen bonding that exists between the DNA. Where you have like your DNA nucleotides, cysteine, thymine, guanine. They're going to bond together, and that's going to make the DNA code, right? Well, hydrogen gas cannot interact with any of this. So that's going to be important, because that means it's not going to create some DNA damage or something, because hydrogen is the smallest molecule there is. So it can easily diffuse into the mitochondria, where the mitochondria actually houses its own DNA as well. So that's actually an interesting aspect. The mitochondria has its own DNA. In fact, you get all the mitochondria from your mother, not your father. So that's actually how we can do genetic testing. And so it's really cool little aspects about this. But yes, hydrogen can go into the nucleus, and it can interact with all these areas. But let's say there's a free radical, like a hydroxyl radical. Well, it can protect the DNA from the hydroxyl radical forming that damage. Okay. So it does not directly interact with the DNA. But then the idea of like gene expression, well, does it have an influence there? Not directly, but because it can modulate the free radicals and oxidative stress, then it will have an effect on gene expression, because those free radicals do affect gene expression, and they can activate pathological signaling cascades that end up being very disastrous for your health. And hydrogen gas can prevent that from happening, and therefore does not activate those gene expressions. At the same time, it can activate other signaling pathways where it's very favorable for our health, for our homeostasis, for the optimal longevity of the cell, and it can activate those specific gene expression or protein patterns by activating certain transcription factors, what they're called, and that activates the DNA to express the appropriate genes.
Wow. This is so funny, because I've been actually studying the mitochondrial DNA and
Oh, cool.
how it goes. Isn't it like 90 something percent from the mother?
Yeah, well, it depends on how we define things, but yeah, the DNA, the mitochondria has its own DNA, and then there's certain proteins and things that are made by the host nucleus, and then that DNA is those proteins can then mesh together, and that's how we can have a functioning mitochondria.
Wow, inheritance is what I call her. The
Yeah.
inheritance from the mother. It's like heritage, hereditary. It's all these her words, right? Inheritance. And then learning about the mitochondrial DNA, it's like, wow, why aren't we looking more at this lineage, right? And the DNA of that. And that's how the questions that I've had with this water and the innovation is, yes, we know what we know about hydrogen now. And some of the questions that I have is like, I wonder if there's going to be in the future about how the hydrogen affects the electricity, or the relationship between those two. Because when I did first learn about the electrons and the electron stealers and the electron donors, I have a joke about it where I'm like, don't be an electron stealer, be an
Yeah.
electron donor, But like that relationship between the electricity and the hydrogen, I'm just curious if you've uncovered any innovative science on that.
Yeah, I mean, I think we have to, again, it goes back to the definition, the defining things, right? Otherwise difficult to really objectively talk about it. Because again, with electricity itself, electricity is flowing electrons, right? You can't just give electricity. If you do that, you can go to your wall and you can touch the two electrodes, right? And you're going to shock yourself because you're giving yourself a whole bunch of electrons, and it will kill you, right?
Right.
So those are not necessarily the electrons that we're talking about. And you're not, when you're drinking the water, you're not getting those free electrons. Those electrons are encased inside the hydrogen molecule itself. And then the hydrogen
Okay.
molecule is a carrier of these electrons.
Wow. Okay, that actually makes a lot of sense.
So then the mitochondria, going to your point, the
Yeah.
mitochondria has, you probably heard this before, called the electron transport chain.
Mhm.
Okay, that what this is amazing process in the mitochondria, where what happens is oxygen is an oxidizer, so it wants electrons really, really bad, right? It's going to pull all the electrons from the food, like when we eat, like, apples or fats or whatever it is. There's a lot of electrons in there, and oxygen wants to oxidize those. That's why if you leave an apple out on the counter, it turns brown, because oxygen is oxidizing that. And if our bodies, our cells can actually control that reaction. It can control this oxidation reaction, and we can extract energy in the form of ATP. That's the energy currency of the cells, adenosine triphosphate. And that's what the mitochondria does. So you have oxygen, which is known as the final electron acceptor. So what happens is the electrons from your apple or from your food, that those electrons get moved into different cofactors like NADPH or NADH, not NADPH, NADH, and then NADH transfers those electrons to the electron transport chain, and it just goes through this process until finally you produce CO2 gas, which is electron poor, and that's the CO2 that we exhale out, right? And then the electrons then end up, and they are attracted to the oxygen at complex 4 in the mitochondria. And when that happens, that oxygen accepts the electrons as well as two hydrogen ions, positive hydrogen ions from the food itself, and you form H2O, water, metabolic water. Okay, that's what happens in the mitochondria in the electron transport chain. That's the electricity that's going on.
Right, right. And oh my gosh, this connects so much. Wow. Um, okay, so I pause for a second. I have somebody trying to get on one of our calls. If you're okay with this, I think we can go for maybe like 15 more minutes.
Yeah.
Does that work for you?
Yeah. I think, I mean, we've talked a lot of stuff. So
I
yeah,
know, and I
so
might I might just have to move things around in our conversation, but I'm gonna have to exit out of this and send you a new link. Is that okay? Do you have
okay.
time?
Yeah, I can do another 15 minutes is okay.
Are you sure?
Yeah, it's okay. Yeah, it's important. We need to get this information out. So
I know.
I
Let me send you a new link. Be right back.
okay.